Hi students, welcome back. In today's video, we're going to do polynomials. We will be doing some exciting questions from exercise 4.1. Are you ready? If you are, let's nail it. Right, let's start off by doing some introduction. I believe we have seen terms such as 2x cubed or minus 5x squared. Right, so we can actually use a generic term to represent all these terms we've come across. Alright, so A can represent a constant term. What are constant terms? Constant terms are such as the examples given could be a number 2, -4, 2/3, etc. Basically, a constant term is just a term that does not change. It's fixed, right? So it could be a real number, a rational number, or anything like that. And A is also called the coefficients of x, right? And then what does N represent? N represent a non-negative integer. So what are non-negative integer? They're basically 0, 1, 2, 3, 4, 5, or 10, etc. Right, so a polynomial is actually a sum of difference of these terms. So examples of some polynomials could be 3x squared minus 5x plus 2, could be 3x minus 5, or it can just be the number 5 itself, because you can actually write 5. You can write 5 as 5x to the power of 0. Right, so 5 is the coefficients of x, right, and the power 0 is actually a non-negative integer. So actually 5x to the power of 0 is also a polynomial. So the word polynomial is a Greek word meaning many terms. Right, so there's some basic things about polynomial. One of it is we need to know the degree of a polynomial. So there's some examples given there on the screen. So the degree of a polynomial in x is actually the highest power of x in the polynomial. Right, so if you look at the first example that I gave you, 4 can be written as 4x to the power of 0. So therefore, the degree, the highest degree here is 0. So therefore, 4 is a polynomial with degree 0. And the coefficients of x to the power of 0 will be 4. So if you look at the second example, 3x plus 1, you can write 3x plus 1 as 3x to the power 1 plus 1. So therefore, this is a polynomial with degree 1. And the coefficients of x will be 3. If I ask for the coefficients of x to the power of 0, then it will be 1. So if you look at the third example, the highest power, if you were to compare, you have the x squared term and you also have the x term. So the highest power is 2. Therefore, this is a polynomial of degree 2. And the coefficients of x will be -7. If I ask for the coefficients of x, it will be -7. If I ask for the coefficients of x squared, then it will be just 2. So for the last one, the highest power is 6. So therefore, that is a polynomial of degree 6. And depending on what coefficients that we are looking for, if you are looking for the coefficients of x squared, then that is 3. If you're looking for the coefficients of x to the power of 4, then that is 5, so on and so forth. Right, so that explains how we can actually find the degree of a polynomial. Right, there are certain things we can do with polynomials. For example, we can actually add and subtract polynomials. But in order to do that, we have to be careful. We can only add or subtract polynomials by putting the like terms together. So what are like terms? Right, so I have some examples on the screen. Right, for example, if you were to look at the left-hand side, any terms with the x squared is considered like terms. So you can have different coefficients. You can have different coefficients. Like for example, the first one that I have, the coefficients of x squared is -2. The coefficients of the second one is 3/4, 4, and 1. So you can have different coefficients, but the term must be x squared, and that will consider as like terms. So if you look at the second example, all right, you have a xy, xy. Okay, so you must have a xy and xy, and you can have different coefficients, so they're considered like terms. So what are unlike terms? So I have also some examples here. Unlike terms, if you were to look at it, you see the power is different. This is x to the power of 5, and this is x to the power of 4. So can you see that the power are not the same? And here also is x to the power of 3. So they all have different powers. So they're unlike terms. Okay. And if you look at the second one, so to have like terms, you must have the same power. You can have different coefficients, but you must have the same power. And if you look at the second one, okay, can you see that you have a x term, but this guy is x squared, different power. You have a y term here, but the power of this y term is different from the power of this y term. So they are considered unlike terms. Okay, so we can only subtract or add like terms together. That's for polynomial. But if you're talking about talking about multiplication, we can just multiply like and like terms together. There's no problem. We'll do some of these questions later on. All right, so having done some basics things about polynomials, all right, now is the time to do some brain activity. So let's go and solve some questions from exercise 4.1. Right, let's look at these questions. To find the coefficients of x squared in the expansions of those two polynomials, the one rather inefficient way is to just multiply every term. You do it like that. Yeah, but that would be rather tedious. So I will not advise you to do that. So what I would advise you to is to actually fish out the terms that we are interested in. And in this case here, the terms that we are interested in is the x squared term. Okay, so we're going to do some what do you call that? Fishing. So if you take this term multiply with negative x squared, what you get will be 2x squared multiplied with negative x squared, and that gives you negative 2x to the power 4, which is not the term that you're interested in, because the term you're interested in is the x squared term. So this is the one that I'm not keen of, so you can just forget it. Right, then you go on to the next one. Take this, multiply with this term, which will just be 2x squared multiplied with negative 3x. And what you get is negative 6x cubed. So again, it's not the term that you're keen on. All right, so we don't want it. Then you repeat the process. Go on to the 2x squared times 1. And you see that, yes, this is the term that I'm interested in, because it will give me x squared. Right. So having done the first term of the first polynomial, you can go on to the second term of your polynomial, and then you repeat the process to get the terms to get the x squared terms. All right, then you can just remove it. Then we go on to the last term. All right, then we simplify it. Okay, and you factorize your x squared. Okay, so therefore the coefficients. The coefficient means is the number in front of your x squared term, sorry. So therefore the coefficients of x squared is 3. All right, that's how you solve these questions. Okay. All right, let's look at another questions. So this question is actually finding the unknowns in the identities, right? So the identities is such that whatever values that you substitute for x on the left hand side, the answers that you obtain will be equals to the values you get, on the right hand side by substituting, of course, the same values of x. That's an identity. All right. So there are three unknowns. Oh my God, not three. There are four unknowns. Oh my goodness. That it's A, B, C, D. Wow, so many unknowns. Okay, but not to worry, not to worry. Let's try to eliminate one at a time. Okay, so let's try to there are two methods to solve this sort of questions, using substitutions or using compare coefficients. Right. So it may kind of look frightening to you at first because there's so many unknowns, right? But if you were to examine it carefully, right, you can actually find the values of A straight away. Yeah, because if you look at the left hand side, there's only ax cubed. There's only a term involving x cubed. And on the right hand side, there's also only a term involving x cubed. Right, so therefore we can just equate your ax cubed on the right, on the left, with 4x cubed on the right, and you will get a equals to 4. Okay, so after finding the values for a equals to 4, you can actually put it back into your identities to get 4x cubed minus x plus 3 Okay, let's see what other things that we can use. Right. How about we do some substitutions? If I'm going to let x, okay, let's zoom into this linear factor. Right, if I can let x to be equals to 1, then do you see that I will eliminate the values of c, the constant, no, the unknown c. So if I let x equals to 1, oh, but I will end up having, I think it's alright, let's try to do that and see. So we're going to let x equals to 1 and see what happens. This guy will be gone already, right? So plus d. I would have 6. Oh, I would end up having 2 unknowns. Right, so I think, oh, maybe we should do, okay, so maybe an easier way will be just using compare coefficients on both sides. That means we just expand out the terms. Okay, so sometimes you really have to do something like that. You just try out one method, okay? I'm just giving you a real life examples of how you can go about solving a question. You try it out, then you realize that maybe I should use another way. Okay, but we already found the values of a, so we can just put it back into your identity. And then I'm just going to expand it out. Expand this guy, so I will have cx minus c plus d. Okay, so I'm going to do some coefficients, compare of coefficients of similar terms on both sides. So can you see that on the left hand side, I don't have any x squared term, but on my right hand side, I have this bx squared, right? So therefore, 0 x squared is equals to bx squared, and therefore b is equals to 0. Okay, and then the cx term here, this term here, okay, will be equals to my negative x. So negative x is equals to cx. So therefore negative 1 equals to c, so c is equals to negative 1. Right, so negative c plus d. So what is left is the constant term. So the constant terms are just this one, negative c plus d. So negative c plus d are the constant term, which is equals to your positive 3 on the left hand side. And since we've already found the values of c, I can just substitute in. So I would have negative times negative 1 plus d equals to 3. So D will be equals to 3 minus 1 equals to 2. So for these questions here, I think it's best to use compare coefficients of similar terms on both sides. Alright, let's look at another questions. For these questions here, alright, I will not advise you to compare coefficients of similar terms on both sides. Why is that so? Because if you look at what we have here, if you're going to expand it, it's going to be quite tedious. Can you see we actually have a cubic terms there. So it's going to be the x plus 1 times another x plus 1 times another x plus 1. Okay, so we're not going to do expansion, alright? So if it's not expansion, then what we're going to do, we're going to use substitution method. So if you were to observe here very carefully, if I'm going to let x equals to 2, what do you think will happen? Yes, you will have a times 0 to the power of 2, which just gives you a times 0 and gives you 0. So if I let x equals to 2, I just conveniently eliminate the unknown a, and therefore I can go on to find the unknown b. Alright, so this is exactly what I'm going to do. So let's proceed. So I'm going to let x equals to 2, or you can just say sub x equals to 2. So this guy will be 0, so don't bother to write it out. So if you simplify this, that will give you negative 19. This will give you 27b plus 8. So 27b will be equals to negative 19 minus 8 gives you negative 27. So b will be negative 1. So after finding the values of b, you can just put it back into your identity. And that will, you will get negative 2x squared minus 7x plus 3 equals to a bracket x minus 2 squared minus 1. Alright, which actually you don't need to put it, the minus 1 there, yeah. Oops, different color. Let's be consistent. Different again. Oh, I think I use red. Alright, so we're going to continue with the methods of substitution. So the next one, I can just substitute x to be any values, and I would like to choose x to be 0 because it's very versatile. Why is that so? Because when you substitute x equals to 0, this term will be gone, this term will be gone. So you only left 3 on the left hand side. And this one will also be gone. Right, so you end up getting 4a minus 1. So 4a is equals to 4a equals to 1. Alright, that's how you do these questions. Alright, let's look at question 6c. Right, 6c looks like a bit complicated. You have like p of x, d of x, q of x, r of x. So many things. Right, so not to worry. If I'm going to represent this using a diagram, you'll see that it's actually not difficult at all. Okay, how do I do it using a diagram? Alright, if you were to recall, I think we have done this sort of questions quite frequently when we are much younger, right? And then do you recall what's the name given to your number 5 inside your division symbol? Yes, this number is called the dividend, right? And this one is called your quotient, right? This one is your remainder. And of course, this one is your divisor. So we're going to extend this knowledge to polynomials. Okay, extend the knowledge to polynomials. So this is what we'll be getting off. Your dividend will go inside the division symbol. So your dividend will be p of x. Your divisor is represented by the symbol d bracket x. Then your quotient is represented by q bracket x. So when you multiply your d of x with q of x, and then you take your dividend to minus off, what you're left is your remainder, where they call it r of x. Right, so d, q, p, r basically are just names given to represent quotients, divisor, dividend, remainder, etc. Why bracket x? Because if you look at what you're given, they're all in terms of x. Okay, so that's why it's bracket x. Right, so this question is basically just asking you to perform the long division. Yes, you just need to perform the long divisions to find your remainder, find your quotients. Okay, so let's do it. Okay, so I'm going to put your dividend inside the division symbol. So the dividend is 8x to the power of 4 minus x squared plus 5. And the divisor, it's wow, quadratic polynomial. Okay, so what do? We take the first terms of your dividend, which is 8x to the power of 4. You're going to divide it with the first term of your divisor, which is 2x squared. And you will get 4x to the power of 2. Alright, 4 minus 2 gives you 2. Right, so here your quotient will be 4x to the power of 2. Right, and after getting the first terms of your quotient, what do? You take the first term to multiply with every terms of your divisor. So your divisor has 3 terms here. So every terms you're going to multiply with 4x squared. So you will have 8x to the power of 4 plus 8x to the power of 3 minus 4x squared. Alright, and then you may want to write it out. Minus 8x to the power of 4 minus 8x cubed, minus because positive times minus this one, this guy times this gives you minus, and then negative times minus give you plus. So if you simplify it, you will get this and this goes off, so you have negative 8x cubed. This guy and this guy will give you positive 3x squared, then plus 5. Alright, so this is what we have. Okay, need to erase off because I need some space later on to do some calculation. Alright, so here, this will become my new dividend. This one now becomes my new dividend. So we take the first term, okay, and then you're going to divide with the first terms of your divisor, which is 2x. So you end up getting negative 4x. So negative 4x come here. Right, so you multiply again with every term. Right, and then you simplify again. 11x squared. Okay, 11x squared. Ayo. Okay, 11x squared. So this one become our new dividend. So we're going to take 11x squared divide by the first term of a divisor, 2x squared. Ayo, I don't like it. You end up getting a fraction, which is 11 over 2. 11 over 2. So never mind. So this become plus 11 over 2. So take 11 over 2 times every terms of a divisor again. So the first term, of course, will get back your 11x squared. Second term will be 11 over 2 times 2x. That will give you 11x. Third one will be negative 11 over 2. Okay, so you will end up getting negative 15x plus 11 over 2 plus 5. 11 over 2 plus 5. 11 over 2 plus 5. It gives you 10 and a half. Or you can leave it as a mixed number, that is 21 over 2. Alright, so we need to express it in the form that the questions require us to. So let's do it. Right, so I have a dividend supposed to express px. So my dividend is 8x to the power of 4 minus x squared plus 5. So this dividend must be equals to my divisor, which is 2x squared plus 2x minus 1 times our quotient, which we have found it here, and plus your remainder, where we have found it here. I think I'll write the constant first, because the constant is plus 21 over 2. I think I don't need the bracket there, because since I'm writing positive first, right? It will be just plus 21 over 2, then minus 15x. Alright, this is how we do it. And why do I stop continuing the division process? If you look at the remainder, the power, the degree of your remainder is 1, and the degree of your divisor is 2. So you stop when the degree of your remainder is 1 less than the degree of your divisor. Okay. Alright, let's look at question 8. Okay, just don't give up. Okay, a few more questions and we will have complete our brain exercise. Alright, so for question 8, part 1, you were asked to find the coefficients of the x squared terms. Alright, so what does this mean? The dot means. Basically, it just means multiplication. It means you just take p of x times q of x. That's all it means. Okay, come, let's do part A. Right, so what we are asked to do is just to take the polynomial x plus 1, multiply with the second polynomial, which is x squared minus x plus 1. Alright, we're going to do some fishing again, fish out the terms, the x squared term. Okay, so we have done something like that similar, we have done some similar questions earlier on. So you just use the x, basically you just work this out and see which is the terms that you're interested in. Yes, I'm interested in x times minus x, okay, because I'm interested in the x squared term. Other than that, I'm not interested in. So similarly, okay, do this and see which is the term you're interested in. Yes, interested in plus 1 times x squared. Then you work it out, you get negative x squared plus x squared. That will give you 0x squared. So therefore, the coefficient of x squared is 0. Okay, let's go on to part B. 2 times px, so it's just 2x plus 2, multiply with okay, I'm interested in the x squared term, so there's no x squared term here, no x squared term here, so I don't bother with it. So I go straight with this. Okay, this times this times this times this. So which one I'm interested in? X squared with 1, yeah. And then go on to your second term. Which one I'm interested in? Negative x with negative x, yeah. Then go on to this one. Which one am I interested in? Plus 1 of x squared. Alright, so let's simplify. X squared plus x squared plus x squared. Okay, this will give us 3x squared. Alright. So therefore, the coefficient of the x squared term we're interested will be 3. A negative 3, sorry, because there's a negative here. Can you see? Negative. So it's negative 3. Okay, so that is part B. How about part C? Right, part C, you just need to take x squared minus x plus 1, multiply with 3x squared plus p of x is x plus 1. Okay, so similarly, let's do some fishing again. Take this one, multiply with this. And then this one times this. And this times this. So that will give you 3x squared. So here, therefore, the coefficients of x squared will be 3. Alright, so that is part I. How about part 2? Part 2 will be easier because basically the degree of your polynomial is the one with the highest power, right? So you just need, usually the highest power will come from the first term. Yeah, so you just need the first term. So for I part A, the first term will be this x times x squared. Gives you x cubed. So that will be degree 3. Alright, and then if you come look at part B, right, the highest power will just be your first term, right? This x squared times this x squared here, x to the power 4. So this will be degree 4. And if you look at part C, yeah, will be this term here and this term 3x to the power 4. So that again is degree 4. So the degree of the polynomial is the one with the highest power of your x term. Okay, that's it. Right, let's look at 11 part 2. 11 part 2 is this without using long division. So you advise not to use long division first. And then you ask to state the degree of the quotients and the remainder when blah 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 is divided by blah blah blah. Alright. Okay, so let's write down your dividend. So your dividend is x to the power 4 plus 2x cubed minus 2x squared minus 2x plus 4. So your dividend is equals to your, this is your divisor. It will be multiplied with the quotient and then you will have your remainder. So the questions ask you for the degree of your quotient. Okay, right. So your quotient will be in the form ax squared plus bx plus c. Why is that so? Because if you were to look at the left hand side, right, this is your left hand side is a polynomial of degree 4 because the highest power is 4. So your polynomial is at degree 4 on the left hand side. So on the right hand side, okay, when you take your divisor times the quotient plus the remainder, you also need to end up getting a degree 4. And if you look at the divisor, it's a degree 2. So I must multiply with a degree 2 also, right? Because then, can you see? Then I will have 2 plus 2 give me 4. Because your divisor is of degree 2. So 2 plus 2 then gives you 4, isn't it? So therefore, the degree of your quotient must be 2. Okay, so therefore, the degree of your quotient. Then how about the remainder? The remainder is usually 1 degree less than your divisor. So if your divisor is of degree 2, then your remainder will be of degree 1. Alright, so that's verified it. That's verified our answer by doing the long division. Okay. So let's do long division. Well, this is a very long exercise. Need a lot of stamina. So don't do it as one shot. You can just do half of it in the morning, the other half in the afternoon. But whereas for me, right, I'm doing it in one shot and it's already 12:15 a.m. I'm still at question 11 part 2 only. Aiyo, no space already. Aiya, how? Okay, never mind, just squeeze a bit. Okay, never mind. So now I multiply with negative 6x. Okay, very bad. This is no standard. Let me do it again properly. Huh? Wait, did I do something wrong? I'm totally confused. Oh, x4 plus x plus 3x squared. x4 plus x cubed plus 3x squared. This one is wrong. Okay, right. So let's check. So the degree of your quotient is 2. Yes, it's correct. And the degree of your remainder is 1. Is also correct. Yes. Right. So we have checked our answer to be correct by using long division. Right. Let's look at question 15. This one is a relatively interesting question. Yes. Okay, because at each time you're actually the divisor actually changed. At each time the divisor actually changes. Okay, so when the divisor changes, then of course the quotient will also change and the remainder will also change. So this is a very interesting question as it really tests you on the concepts of your divisor, your quotient, and your remainder. All right, so step 1, what we can do is we're just going to write down the generic terms for all your generic term for your dividend, which is p of x, equals the generic term for your divisor d of x times quotient q of x, and then plus remainder r of x. Let's look at part 1. Part 1, you are told that is divided by 6x cubed minus 7x plus 1. So that will be your divisor. So this is your d of x. So we're going to substitute inside this as your d of x. Then of course, then if you go back to your dividend here, so if this is your divisor, right, then of course 3x squared plus 5 will become your quotient. That will be a quotient. Then your remainder will be whatever that remains there lah. Okay, so therefore here we can say that the quotient is equals to your 3x squared plus 5. Then your remainder will be equals to your 3x squared plus 6. Okay, so part 1 is relatively alright. Part 2 is a bit challenging because now that your 3x squared plus 5 becomes your divisor. Right, so let's write it down. So it becomes, this one becomes your divisor. Okay, so if this is your divisor, I think we can actually factorize this out. You get this. Right, and then simplify it. So this one is slightly more complicated than what we have done earlier on. Alright, so if you compare with the generic term, you'll see that this is your divisor. Then this guy become your quotient, and this become your remainder. So therefore, your quotient now is equals to 6x cubed minus 7x plus 2. Then your remainder now becomes 1. Okay, can you see the difference between part I and part 2? Okay, part I, you can't actually factorize your 3x squared plus 5 because 3x squared plus 5 is your quotient. You can't factorize the quotient, but you can actually factorize the divisor. So for part 2, when 3x squared plus 5 becomes the divisor, you can actually factorize it. So let's look at part 3. Let's see what happened in part 3. So if it's divided by, oh, so now this whole chunk of thing become your divisor. If the whole chunk of thing become your divisor, right, then the quotient has to be 1, right, isn't it? Because your 3x squared plus 5 times 6x cubed minus 7x plus 1 now become your d of x. So your q of x will have to be 1. Because it's quotient times your divisor will gives you right then plus a remainder. So your remainder will still remain as 3x squared plus 5 plus 1. So from there, therefore, your quotient will be equals to 1. Then your remainder is equals to 3x squared plus 6. Right, let's look at part 4. So part 4, you're given that you need to take p of x minus 1 divided by this. For part 4, explain whether 3x plus 1 is a factor. Oh, okay. Right, so we just do as what they ask us to do lah. So the question says take p of x minus 1. Right, so your p of x is just 3x squared plus 5 times 6x cubed. So you will have 3x squared plus 5. So give you 3x squared plus 5. Oh, good. So can you see there's a common factor here? Common factor, so we can factorize it. Alright, so this one, if you're going to use a generic term to represent it, this is your divisor. This one will be your quotient. So plus remainder, but can you see your remainder is actually 0? Right. So since the remainder is equals 0, 3x squared plus 5 is a factor. Okay, right. Yeah, we have come to the second last question. That is question 18. Okay. Brace up, brace up. We can do it. All right, let's look at part 1. So part 1, we're given the blah 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 equals to blah 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 and blah 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 is an identity. State the degree of the polynomial q of x. Oh, that's easy. So the degree of the polynomial q of, oh, that's quotient. So we need to state. All right, that's not difficult also. All we need to do is, okay, if you look at the left hand side, right, left hand side here is of degree 4 because the highest power is 4. So left hand side must be of degree 4. Oh, sorry, left hand side is degree 4. So right hand side also must have degree 4, right? So if you look at the right hand side, is x times x minus 1 times x plus 1 with the quotient. Okay, so we just need to multiply the first term. So the first term will be x times x, give you x cubed. The rest we're not interested in. So in other words, if you want to get x to the power 4, right? So to get x to the power 4, then my quotient has to be x to the power 1, right? Because 3 plus 1 then give me 4. Because on my left hand side is a 4. So my right hand side must be 3 plus 1 to give me 4, right? So therefore, when it says state, you just write it down. So these are all my explanation for you. These are all the explanation. So once you understand what is going on, right, you don't need to write all this down. This is just the explanation. So you just state means you just write down. So therefore, the degree of the polynomial q of x is 1. Okay, because this is 1. Right, so this will be your answer. And all these are my explanation to you. Okay, let's look at part 2. Find the values of a, b, and c, hence state the remainder when this is okay. Find the values of a, b, and c. So, right, so basically you just go about to solve the identity lah. X4. Okay, 加油加油, don't give up. Aiyo, so many unknowns to solve. Right, 3 unknown. Okay, actually 4 because you also have q of x. So you realize that the way to do is just substitution, really, because I wouldn't know what q of x is. I really would not know what q of x is. So the only way is just to eliminate. I need to eliminate q of x. So to eliminate q of x, just zoom in into all our linear factors here. So first of all, I think we can use this guy. We can use this term here, x minus 1. You just let x equals to 1. If you let x equals to 1, right, I basically just kill off all this thing here. Oh, no, wait. Sorry. I think it's better to let x equals to 0. You know why? Because if you let x equals to 0, right, okay, this whole chunk of thing will be gone. This 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 will be gone. And then we can find c. Right. Yes. So we're going to let x equals to 0. So gone. So left negative 2 on the left hand side. On the right hand side, gone, left c. So c equals to negative 2. Right. So after finding c equals to negative 2, let's put it back into our identity. So the next thing maybe we can do is let x equals to 1. You have to let x equals to 1 really, because you just need to eliminate q of x ma. X equals to 1. Okay, let x equals to 1. So you will have 1 minus 2 plus a minus 2. So this whole chunk of thing will be gone. So equals to 4 plus b plus c. So b, oh, already found c to be negative 2. You can just plug it in. So we would have negative 3 plus a equals to c is negative 2, so 4 minus 2, so 2 plus b. I think I'm going to make a the subject. I would have to end up getting two equations solved simultaneously, no choice. 2 plus b plus 3, so that will be b plus 5. Call this equation 1. So the second substitution, you see, I've already exhausted x here. I've also exhausted x minus 1, so I'm only left with this term here, x plus 1. So I'm going to let x equals to negative 1. Okay, so I would have negative 1 to the power of 4. So this whole chunk of thing will be gone, huh? So 4 negative 1 squared. C is negative 2. Let's simplify. That will give me 1 plus 2 minus 2. A plus 1. That will give me 4 minus 2 minus b. So I'm going to sub equation 1 into 2. A is b plus 5, so b plus 5 plus 1 equals to 2 minus b. 2b equals to 2 minus 5 minus 1. Negative 4. B equals to negative 2. Alright, so sub b equals to negative 2 into equation 1. You have a equals to negative 2 plus 5 gives you 3. Alright, so we have found the values of a and b. So that put it back into our identity. Okay, I'm going to meet you at the next slide. Alright, so from part 1, we have managed to find the values of a, b, and c. From part 1, we found a to be 3, b to be negative 2, c to be negative 2. So we're going to plug it all into our dividend. So our dividend is equals to our divisor times our quotient. Values of b is negative 2. C is also negative 2. Alright, so I think we can you see if you can simplify this. This will be your a minus b. This will be your a plus b, right? So that gives you a squared minus b squared, right? So these two terms here, when you expand it, you get x squared minus 1. Then when you expand further, you have x cubed minus x. Right, we're going to use a generic term again. So this will be my divisor. And my quotient is there. So then this guy will have to be our remainder. Right, so you ask to state the remainder when it's divided by. So yeah, so this is our divisor. So from here you can see that this will be our remainder. So therefore, our remainder is equals to 4x squared minus 2x minus 2. Yeah. Right, let's come to the last questions. Hallelujah. Oh my God. Alright, so you're given your p of x, two polynomials there, p of x and q of x. Find the remainders when p of x and q of x each divided by x minus 2. Hence, deduce the remainder when blah 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 divided. Oh, okay. Right, never mind. Let's tackle one at a time. So you ask to find the remainder when p of x are divided by x minus 2. Okay, so let's go and do it. Alright, so for part 1, so p of x, we can write it as divisor, right? Times your quotient, right? Plus the remainder. So your p of x is 3x cubed minus 5x squared plus 4x minus 9 is equals to, the divisor is x minus 2 times the quotient, then you ask to find the remainder, right? Okay, so basically what we are doing here is that, okay, 0 into this guy here. So we just let x equals to 2, so we can eliminate q of x, and then from there we can find a remainder. So we're going to let x equals to 2. So therefore your remainder will be just be equals to, right, just use your calculator to work this out. 3 bracket 8 minus 5 bracket 4 plus 4 bracket 2 minus 9. 3. So remainder equals to 3. And then for q of x, we stay at part 1. So let's write down q of x. So q of x is, so that gives me my x minus 2 times q of x plus remainder. So let x equals to 2. So remainder will be just 2. And that gives you eh, 2 times 47. Alright, so what are we asked to do next? So we settle the first two parts already. This one done already. So hence deduce the remainder when p of x plus q of x. Okay, right, so again let's do one thing at a time. Let's do this first. P of x plus q of x. So we are just taking p of x plus q of x. So the when is okay, so the remainder of p of x is 3. The remainder of q of x is 47. So therefore the remainder for both of them would have to be 47 plus 3 lah. Okay, then how about the other one? What's the remainder when 2 times p of x? Okay, so if it's 2 times p of x, right, so you will end up having, okay, from here, this is what we started off, right? So I'm just going to multiply by 2 throughout. So we found out earlier on that the remainder for p of x, when it's divided by x minus 2, the remainder is 3, right? So if you're going to multiply it with the 2, then the remainder will become 3 times 2, 6, right? So this remainder will become 3 times 2, 6, right? Because this one here becomes, this one we found earlier on to be 3 here, can you see? So it will be just 2 times 3. Write it the other way around, then you can see 2 times 3. right, give you 6. So the remainder for 2p of x. So the remainder for qx will still remain as 47. Huh? So therefore the new remainder, therefore the not no new remainder wrong. Therefore the remainder for 2p of x minus q of x will be 6 minus 50? No, not 50. Just now the remainder we get for q of x, where is it? Here, 47. Will be 6 minus 47. Negative 41. Okay, so that ends of all the questions we need to do for exercise 4.1. Right, I must admit it's really very tedious. So start to break it up into 2 parts. Okay, don't do it as one shot. It's very tedious. All right, happy trying.